Welcome to section 3, leveraging the continuous deployment pipeline to build the production environment. In this section, we will build the production environment so that we can deploy the application to it. We will start by bringing the production Kubernetes cluster in GCP up and running. Then, we will configure the continuous deployment pipeline to deploy the application to production. But we will also let the pipeline continuously deploy changes to the production environment itself. So let's get started. In this video, you will learn how to create a Kubernetes cluster in GCP with Terraform and deploy the application for the first time via the continuous deployment pipeline. We will push and pull images from the Docker registry and configure the pipeline to create and then deploy our application to our production Kubernetes cluster. Let's get started. In our code editor, let's create the Terraform file where the production environment resources will be defined. Now inside that file, let's add the Terraform resources necessary to create the Kubernetes cluster in GCP. In order to create a Kubernetes cluster, a couple of Google Cloud APIs are required first. As you can see on screen, the Google Project Service resource can be used for that. In the file, you can see that I have defined two Google Project Service resources. The first one enables the Google Resource Manager API. The second one enables the Container API instead. Note how I have explicitly declared the Container API is dependent on the Cloud Resource Manager API. In Terraform, you can explicitly declare dependencies between resources by using the depends-on resource parameter. By doing so, you will let Terraform know what should be created first, and so it will prevent errors in scenarios like this one. Then you can see the Google Container Cluster Terraform resource. I am declaring that I want to create a Kubernetes cluster in GCP. The cluster will be called Production Cluster, and it will initially be made of one node in all three availability zones. Now, with all the Terraform resources defined, let's create the production environment. From our terminal window, let's run the Terraform plan to see what it is about to happen. As you can see, the plan is saying that a Kubernetes cluster will be created, and before that, the necessary Google APIs will be enabled. Let's apply the plan. We are now creating the three resources that we initially talked about. The first one is the Cloud Resource Manager API, the second one is the Container Google API, and the third one is the cluster, which is dependent on all the two. Now let's wait until the command finishes. With the plan applied successfully, if we go to the GCP console now, we should see the Kubernetes cluster up and running. Let's go and check that. From the GCP console, click on the menu icon on the top left corner of the page, and under the Kubernetes Engine section, click on the cluster menu item. As you can see, we have a Kubernetes cluster up and running called Production Cluster, just like we expected. Given our application is a Docker application and Kubernetes orchestrates container images, we therefore need a place where to store the application image somewhere first. A good place to store Docker images is the Docker Hub. Let's go to the Docker Hub page. The Docker Hub page is available at hub.docker.com. In this course, we are going to use the Docker Hub as the registry to store the application images. In a real-world production environment though, you will most certainly want to store your application images in a private registry. If you don't have an account on Docker Hub, you can easily create one on their sign up page. Once you have signed up on that, you should be ready to store the application images in there. Now let's go build and then push our application container image for the first time to Docker Hub. What I'm doing now is running the usual docker build command to build the Docker image. After the docker build command has finished, before we can push images to the Docker Hub, we first need to log into it. Now let's first log in into the Docker Hub from the command line and then push the application image to it. I have stored my Docker Hub account password in a file called docker-hub-password.txt. Its content will be read and piped to the docker login command. When committing the new changes with Git later on, please make sure that you exclude this file. After successfully logging into Docker Hub, let's push the container image. Pushing the container image may take a while, so let's wait until the command finishes. With the container image uploaded to Docker Hub, I think we are now ready to deploy our application to our production Kubernetes cluster. If you recall from our previous video, we configured our pipeline to deploy the application by using the kubectl CLI tool. In the deployment pipeline step, the kubectl command is referencing a file called myapplication.yaml. We don't have that file yet, so let's create one now. The file will contain the definition of our application running in production. Okay, so let's go through the content of the My Application YAML file. Starting from the top, we are first defining a Kubernetes deployment resource called My Application. The deployment will be made of 2 replicas running the application. As you can see from the code, we are referencing the application container image we created earlier. Then if you scroll down, you can see that we are also defining a Kubernetes service resource. The service will be of type load balancer and it should be accessible on port 8000. This should be enough to allow us to deploy the application on Kubernetes. You may be wondering how the kubectl utility is going to be able to deploy to our production environment without some form of authentication. In fact, by default, the continuous deployment pipeline would not be able to deploy anywhere. We will have to provide the necessary credentials to do its job. This is where Concourse parameters and parameterized pipeline come into play. In Concourse, it is possible to declare parameters to inject inside jobs as environment variables. As we will need to authenticate with GCP in order to deploy to the Kubernetes cluster, we will leverage this capability and use it to our advantage. Now let's go and update the pipeline YAML file with the new changes. As you can see, in the deploy to production step there is now a service_account_key parameter defined. That parameter is being assigned a service_account_key variable surrounded by double parentheses. In Concourse, anything that is wrapped in between 2 sets of parentheses is considered a variable being injected from somewhere. In this case, we are going to pass the service account JSON key file. To do that, let's create another file which will contain all the possible parameters we need to pass to our pipeline. Let's create a file called concourse-parameters.yaml. With the file in place, let's copy the content of our service account key JSON file and paste it in there. Now let's wrap its content in single quotes, then remove the new lines and finally escape the literal new lines declaring it. We escape the literal new lines so that problems don't arise later in the pipeline steps when it comes to echoing and reading the content of the service account JSON key. Now let's open the pipeline YAML file again. In the last step, you will notice the run command of the deploy to production step has changed. Before we can use the kubectl CLI utility, we first need to authenticate with GCP as mentioned earlier. What we are doing in this case is to store the service account JSON key into a file and use that file to authenticate with GCP. After the authentication, we are pulling the Kubernetes cluster credentials via the gcloud CLI utility and finally deploy the Kubernetes resources with the kubectl utility. Before we can tell Concourse to use this new modified version of the pipeline though, we first need a couple of other things. First, we need to explicitly tell the Django application framework to allow all traffic, because by default, Django only allows local hosts. Let's therefore open the settings.py file. Then, in the allowed host variable, add the quoted asterisk to the empty list. Now let's build a new container image and push it to the Docker Hub. Once Docker has finished building the image, let's push it. With the docker build command done, let's push the image now. Now with all the changes in place, it's time to finally update our continuous deployment pipeline. From the command line, notice how I am passing the load vars from parameter this time. That parameter refers to the file we created earlier that contains the secrets we need in the pipeline steps. For the purpose of this course, it's fine to manage secrets this way, but in a real production environment, it's highly recommended that you use other secrets management tools such as HashiCorp Vault, for which Concourse has an integration. Now let's update the pipeline and see what happens. You can see that there are changes to our pipeline step to confirm. Let's confirm. With the configuration updated, let's head to the browser window and see how the pipeline has changed. As you can see, this time the deployment step was successful. That means we should have successfully deployed to the production environment. Let's head to the GCP console to verify the status of the Kubernetes resources. From the GCP console, let's check whether the services and workloads have been created. As you can see, we have the pods running in our cluster. Let's now check the services. The Kubernetes service has also been created. If all went according to plan, by clicking on the IP on the page, we should see the Hello World page on the application. The Hello World page is up and running. That means we have successfully deployed our application with our continuous deployment pipeline.